I would like to describe a field in which little has been done, but in which an enormous amount can be done. This field is not quite the same as the others in that it will tell us little of fundamental physics, but it will tell us much about the strange phenomena that occur just below our perception. In contrast to the natural philosophers of the past, the scientists of this field delve into the recesses of nature and show how she works in her hiding places. Their quest is to understand and create the imperceptible. After all, there is plenty of room at the bottom.
Hello and welcome to the Materialism Podcast, an exploration of the past, present, and future of material science and engineering. My name is Taylor Sparks, and I'm an associate professor of material science and engineering at the University of Utah, although here, for 1 year, I'm at the University of Liverpool. And while I'm in Liverpool, a big goal of mine is to connect with the UK materials community. And one way to do that is by interacting with UKRI. And we have a series of episodes sponsored by them. And today's will be on this family of future technologies in foundational industries. And the emphasis of today's is to talk about cross-sectional collaboration. And this is something that material science does naturally. Those who've studied material science know that this is an intentionally broad major as opposed to a deep major. We learn about all the materials, right? You learn about ceramics and polymers, and you learn about metals, and you learn about composites, and you go into some depth, but you intentionally learn the breadth. And you know what? It doesn't end there. When you go and actually go to industry, you're still collaborating and you're still working in team settings. And that's the point that we're going to talk about today is this cross-sectional collaboration all the way from the supply lines where chemicals and materials come from to their end use. And to do that, we have two excellent guests. We have Bruce Adderley from UKRI, who sponsored these mini-series, so special thanks to them. And we also have Alistair Sanderson of Unilever. You guys want to introduce yourselves?
Yeah, hi, I'm Bruce Adderley, and I'm Director of the Transforming Foundation Industries Challenge at UKRI. My background is over 20 years in the steel sector, with other periods working in academia to help them translate their research into industry. And much of that time I've been working on energy, carbon, and wider environmental aspects to do with the industry.
Okay, fantastic. And Alistair?
Hi, so I've got 31 years now under my belt at Unilever, so I'm a chemist. Most of that time I've spent working in the home care group, making formulations and products that you'll all know and love for cleaning and caring for your homes. My current role is platform leader for the Carbon Rainbow. So essentially I'm working with the upstream value chain partners to move us away from fossil carbon and only use renewable and circular carbon in our materials.
That is awesome. So when it comes to this idea of cross-sector collaboration, what interest do you have in this area?
So from my perspective, I can remember over those decades seeing really good examples of collaborative projects, how they can bring benefit to your innovation, but sometimes they arose through random happenstance. Something needed to be worked on. There happened to be the right group of people talking, and the collaborative project occurred across companies, but not enough strategic thinking about working collaboratively, particularly across the foundation industries and through their supply chains. So really, when the opportunity came to get involved in the Transforming Foundation Industries Challenge, I just absolutely jumped at it to try and push this further.
We first came across the Transforming the Foundation Industries Challenge through the Chemistry Council work in the UK. That extended into the work we were doing with the Science of Chemical Industry engagement. So we've been working closely with Innovate UK and KTN with those initiatives for a good 2 or 3 years now. And a funding round became available for TFI, which is Transforming the Foundation Industries, which really enabled us to link up what we were wanting to do with what the Transforming the Foundation Industries group were trying to achieve.
So Bruce, as the director of TFI, can you step it back a little bit and tell us about where did this come from? Where did this initiative come from? What are the main goals that you hope to achieve with it?
So TFI, as we call it, the Transforming Foundation Industries Challenge, is one of roughly 20 challenges within a wider challenge fund. So 4 to 5 years ago now, the UK government agreed a significant funding programme to address challenges faced by industries right across the economy. And it's actually in total a £2.8 billion investment in these 20 challenges. We're a Wave 3 challenge, and in Wave 3, sectors were invited to put forward expressions of interest in terms of the great big challenges that they felt they were facing. And essentially what happened is all of the different foundation industries each put in an expression of interest for a challenge. And then as we looked at those, we went, now hang on, these guys are all facing a series of big challenges, many of which they've been attempting to resolve for the last 10 to 20 years and haven't got through the barriers. Yeah. And we said, okay, this is an opportunity to get them working together. We had those conversations and we created the plan for this challenge out of those EOI. And hence we have this program of work, which has now been ongoing for about 3 years. Between industry and the public sector funding, it's a total of roughly £150 million being put into this innovation programme. So it's quite extensive. We're creating a range of things, but including a significant collaborative R&D programme. We're spending roughly 50% of the funds in that area.
Yeah, that's massive. So how does this, I'm thinking in terms of the US system, which I'm more familiar with, how big is this funding initiative compared to other things that are funded?
I'd say we're actually a small to medium sized challenge within that £2.8 billion funding program over a few years. So the challenges in general have gone from about 40-50 million pounds, but the biggest is 200-300 million in scale and scope. So there's a whole range. The UK through UKRI currently spends about £8.5 billion on science, innovation and technology, and that's due to rise to about £11 billion a year within the next 2 to 3 years. So there's a significant investment overall in this area.
Okay. So Alistair, on the other side, as now a corporation who's obviously going to be participating in these TFI initiatives, what's your driving force and what does it look like for you? As Unilever is a very large company, when you say cross-sector collaboration, is that all internal to Unilever across the different divisions, or are you actively reaching much more outward?
We're very much reaching outward these days. We don't make chemicals, so everything that we use in our products and our formulations are purchased from the open market. And what that means is we need to be able to buy the materials that we need. To do that, we need to work with collaborations. We need to work with the extended value chains, because what we found is that if we simply go to the market and say, can I please have a material that's sourced from a given form of carbon, then the answer is no. No one sells me that carbon. I can't make you that. But if I go right to the beginning of the value chain, so the people who are producing carbon emissions, they turn around and say, well, no one wants to buy these. I just let them go up the chimney. So we are working very much end-to-end value chain these days to really try and stimulate how we fit that chain together. So we're very much a demand centre. So we're demanding from the market a change, and we're working with the extended value chains to create that value markets to create that change.
So has the real change primarily been communication?
It started off in the early days of communicating to make sure everybody was on the same page, getting our message and strategy out there. These days, it's much more than communication. It's actually working with each member in that extended value chain to enable the change that we need to make. So it's not a very simple change. It needs all the players in the value chain to work together seamlessly, like cogs in a wheel and a clock.
Do you have some examples where this has been put into practice already?
The really good example that we're currently working on is a project called Flue to Chem, which is funded by the Innovate UK and the Transforming the Foundation Industries. So in that project, we've basically brought all the players from the value chain, from people who emit carbon directly to the atmosphere today. And some people call that waste. It's not waste, it's valuable carbon, which if we can utilize, can do the same role that, say, fossil carbon does, or carbon that you might harvest and cultivate from plants. So we've set up a collaboration with the emitters of this valuable carbon, so Tata Steel and UPM and Holman, so that's a steel producer and 2 paper producers, and we're going to capture their carbon using appropriate carbon capture technology, some of it very new, some of it optimized from historical carbon capture technology. And when we've captured that carbon, we're going to convert that into the key building blocks that enable all the ingredients that society uses today for consumer products to be made. So we'll be able to make some ethylene, we'll be able to make some longer chain alkanes, which are the backbone of many of our ingredients that we use in home care. And then we've got people who take those component intermediates and make them into, in the case of Flue to Chem, specifically into a surfactant. So that's one of the ingredients that does the cleaning. Croda will make the surfactant. And then once we've made the surfactant, you need to be able to demonstrate that it works. So the surfactant will be tested and demonstrated with 3 major consumer goods companies. So we've got Procter & Gamble, Reckitt and Unilever all at the table, because we all use very similar materials to these. So we want to show that we can use the material that comes out of this new value chain. And it's not just home and personal care types of products, but Tata are also not only a steel producer, but they use quite a lot of paint to protect their steel and stop it going rusty. So they're looking at putting these surfactants into and demonstrating that these materials can also find application in coatings. So this is a really nice example of that, where we've started at one end of the value chain, so the source of the carbon emission, which if we didn't capture it and utilize it, ultimately ends up in the atmosphere and is a greenhouse gas, so it contributes to global warming. We can take that carbon, we can add value to that carbon and convert it through the entire value chain and demonstrate that it does the job that we utilize today.
I think that's so cool. You take something like Tata Steel, right? The CO2 is coming out. You're actually turning it into a commodity, ending all the way back up at steel as a coating. Super cool. We haven't done an episode on carbon capture. We've got some coming up planned. But for those that aren't familiar, can you tell us a bit about that process? Is it actually commercially viable? Does this lead to really high costs? I imagine there's a lot of platinum group catalysis and things like that involved there.
So the reality is that carbon capture and storage is a well-proven technology, certainly carbon capture. It's been used around the world to a certain scale for decades. And I would say in the US principally, the sort of storage type element has also been used for a long time, especially with regard to the production of oil. So the CO2 has been captured, moved through pipelines, and then used to help push more oil out of wells. Now, that's clearly not an ideal scenario that we sit in now, but fields like the Sleipner field in the North Sea, so that's off the east coast of England and the west coast of Norway, has been capturing CO2 and putting it under the North Sea back into old oil and gas fields for 20 years now. So inherently, the technology is known and developed. It's all about making it better, faster, more efficient. And that's where all the research primarily lies now. And of course, scaling up the whole industry to deal with the scale that we need to be storing literally gigatons of CO2 a year within the coming decades. And therefore, there's a massive nascent industry just kicking off, really.
But I like what Alice is saying, is that instead of just taking it in its current form and using it as a gas and inject it into a well where, the pressure gets better extraction of oil or gas, which is a great use of it. You're talking about using it as a feedstock. Like that's a chemical feedstock turning into other ethylene or whatever else you mentioned. And that's a cool process. I was just curious about, I'm excited to see a company like Unilever doing this because you're selling products, which means that you found a way to make that cost effective enough that people actually buy the products using that as your starting material. We'd heard a great example then of steel emissions all the way into commercial products like surfactants and paints. Are there other examples that TFI has had some success stories with in these sort of cross-sector collaborations for foundational industries?
Yeah, so we have a series of demonstration projects now running, Flutichem being one of them, but a couple of examples that link the steel and cement sectors together are a project called Cement to Zero. So essentially here we're looking at, there'll have been a construction project on a building and it's reached end of life and it's being demolished, and there'll be lots of old concrete and cement from there. And what academics at Cambridge University have taken through small sort of lab scale, and we're now taking to pilot and demonstration scale, is that you can take the old cement from such rubble, and you can use it as a flux in the electric arc furnace steelmaking process.
Wait, what? The cement becomes a flux? Can you tell us?
The cement becomes a flux in the steel making, in the EAF vessel, for those who know what one is, where you're making steel through an electrically powered process. And then on the surface of the metal there, when it's used as a flux, you form what's known as a slag. Yeah. Now, if you've used the right old cement as that flux, you eventually end up with that slag can then be put back into the cement manufacturing process as well, so that the product again completely cycles from you're taking it from a building that's been demolished, is being used to replace current fluxes in the EF process. You're also obviously you're melting the scrap steel from the building in the EF process, and then you're getting a materials that you can put back into buildings. So that's a great project that we've got running. And another project that goes by the name Rectify, that's RECTIFI, if people want to look it up. Here we're looking at building an enhanced or new value chain in the UK economy in terms of recycling steel and other constructional materials. So we've got people in the construction market, again, Tata Steel, as you can tell, I mentioned again, they're being very proactive here, along with a big metal recycler, EMR, to put in place all the missing bits of the jigsaw so that the UK steel and construction materials recovery supply chain can become complete and we can retain and reuse the highest value materials. So at the moment, there's a big problem that, for instance, steel scrap, it's sold in tonnages of mixed high value and low value steel, and we need to have that innovation to be able to separate those out and feed these materials in the right direction. So we got a great project running there, making that happen as well.
That is awesome. And I love seeing these really mature technologies reinventing themselves. Like that is a really exciting way to and it's exactly transformation foundational industries, right? You're bringing new life into these really well-established things to completely change the way that they're being manufactured.
And I think that's a key thing from the perspective of how we look at it as public sector funding. So I work at UKRI, but within UK, which is like the business-focused innovation element of UKRI. But we've always said that innovation, from our definition, includes taking a technology which is successful in, say, one industry and maybe changing it a bit so it's fit for deployment in another. And that absolutely fits with what we're trying to achieve with TFI, utilization between the industries, as well as being able to use the scale and scope of all the industries working together to drive innovation faster and at a bigger scale is an absolute imperative.
That is so cool.
I think there's another really interesting example. Again, it's not directly related to steel, but the Sustainable Aviation Programme that's running in the UK is a really nice example of capturing that carbon and using it to make aviation fuel, where that aviation fuel hasn't come from virgin fossil carbon. So that allows you to effectively fly your aeroplanes without a reliance on virgin fossil carbon. So you can take those emissions and make jet fuel. The really interesting thing, which is one of the drivers that sparked my interest about 5 years ago, is that many of the ingredients that are used in home care products are actually co-products from the petrochemical industry that produce jet fuel. So if you can make jet fuel from CO2, in principle, you can make anything you would like from CO2. So I think that the Sustainable Aviation Thrust is a really strong example of that carbon capture and utilisation over and above, as Bruce says, the need to store excess carbon.
So, Alistair, have they found a way to make this economical?
So at the moment, it's not a direct comparison with fossil-based carbon feedstocks. It is going to be more expensive based on the technologies that are available today, but it's not many multiples more expensive. You're looking at the moment with technology you can take from various centres, and you're looking at somewhere between 5 and 7 times the cost of fossil carbon. Now, that sounds frightening when you look at it the first time. But when you think this is in a nascent industry, scale has to be built, and technology isn't as far advanced and optimized for the applications we're looking at. One of the key things we want to achieve in Flutichem is once and for all a real clear understanding of the economics of the end-to-end value chain, so we can see where is cost coming from and where do we need additional points of intervention to make that competitive. So we've got a big work package which has been led by the University of Surrey, which is looking at the techno-economic analysis and the life cycle analysis, so we can actually say, look, with confidence, is this better for the environment? We'll believe it should be. We'll be able to get the numbers and the evidence behind that. And we'll also be able to understand exactly what the techno-economic analysis is and where the costs are coming from and at what point we need to intervene, which could be intervening with additional focused R&D to tackle big challenges. It could be more policy related. But the important thing is, it's not directly cost comparable today, but any new technology isn't. If we look at flat screen televisions 20 years ago, they were phenomenally expensive. Now they're almost disposable items. So over the next few years, we'll see that emerging and it becoming more cost competitive. And this is the first time, certainly in the UK, that we've built the entire value chain end to end so we can get full visibility of the costs at every element of the interaction with the carbon.
So if I could pick up from that and just broaden it a bit to some of the other foundation industries. As a challenge, we've supported a centre by the name of Glass Futures. They're putting in essentially full-scale pilot facility in St Helens. Yes, principally focused on glass, but it will be able to support a number of the other foundation industries as well, as in fact also already doing so with steel and cement. But they, along with the large glass companies in the UK, have already been trialling biofuel in glass furnaces, essentially 100% use of cullet as a raw material. So that's old glass, basically. And they've managed to do production runs where the carbon footprint of the glass produced is 90% down from standard using natural gas, normal raw materials. Now, that glass does cost more than your standard glass at the moment, but it isn't multiples that Alistair was just talking about in terms of the chemicals. It's a small number of tens of percent type numbers. And what's happening is the big drinks manufacturers have realized that it's within reach, yeah, of having a completely decarbonized glass for their furnaces. And therefore, they also are engaging in this sort of demand-led innovation space and saying, okay, this is what we want. We're understanding the cost structure and we can see that it's viable going forward. So we're going to pursue it, which is great to see.
And I think that actually brings in a really story, if you like, about much of the example that Bruce has just talked about is the benefits you get from changing and managing the energy sources to run the process. What we're doing in Flutichem is not only are we changing the energy to make the molecule, but we're changing where the carbon within the molecule has come from. And I think that's why the cost structure is slightly different when you look at it for application in chemicals. This isn't just about the energy taken to make the chemicals and where that came from. It's where did the carbon within those molecules come from?
Well, we've seen some, what I think are really compelling instances of what you're trying to accomplish with this transforming foundational industries. Looking forward, how do you see this evolving? Because this is a new initiative. So what would you like to see going forward in the future?
So I think what we're saying is that these forms of collaboration, both across the foundation industry sectors and through supply chains, are working. Yeah, they are proving beneficial. We're getting lots of new innovation, making lots of progress that we weren't 3 or 4 years ago. And so we want to see this happen more and more. And I would love to see frankly, a publicly supported demand-led innovation program. Yes, focus or having a core with these materials at the center, but right from the off, directly involving, I'm not going to say the end consumer because that is you and me as an individual, those companies that the foundation industries supply. Yeah, so eventually along the supply chain to Unilever, for example, but in terms of the glass manufacturers, it will be the people who are going to eventually construct buildings, or they're the big drinks manufacturers, and directly having them involved in the innovation program from day one. What we've done at the moment is get companies within the foundation industries involved at day one and got them to collaborate, and we're seeing the success of that. But in doing that, that has tended to draw in the companies that they work with up and down the supply chain to an extent, and to a great extent in the project that Alistair's been describing. And it's proving that demand-led focus is where we need to go next.
Alistair, any specific insights with respect to the supply chain and the chemical?
I think the specific insight I would have is how we unlock that affordability. So I think we've seen, if we look at parallels with the aviation fuel industry that we touched on earlier, by law, you have to use a certain proportion of the aviation fuel that isn't coming from fossil carbon these days. And I think when you're bringing a new industry together, that is a nascent industry like this, we need some form of regulation to make it legal that it has to be used. Whilst that will enable us to start building scale, it will enable the value chain to start being created. And I think with projects like Flutichem and the support of the UK, those industries should be able to take a good foothold in the UK itself. So what I'm looking for is for the next stages of this project to be able to start building the extended value chain. So being able to do this at commercial scale and have a requirement to have to put them into products. It will be a journey, it will take time, but with all new technologies, unless you have a real legal drive to do it, then it's going to take much longer than it would otherwise to go through. And I think that's the beauty of Flutichem. It gives us the chance to show that it is possible. And then it's simply a choice for us to invest in that for the future or carry on as we are now.
So I'm curious, if you had a magic wand and you could change one thing about this whole process to make it easier to adopt this, sort of eliminate challenges, what would that be?
My magic wand would be a process which avoids the need for green hydrogen and the associated costs of green hydrogen. Because we can talk about carbon capture and we can talk because that's what's giving us the problem from the greenhouse gas perspective. But you can't make a hydrocarbon, which are the materials that we need, without hydrogen. And at the moment, it's the hydrogen that fundamentally alters the cost structure of the products. Capture of carbon's not excessive. The cost of carbon capturing carbon and storing it isn't excessive. It's the hydrogen associated with it. So if I could wave a wand, I'd want to have infinite renewable energy. And from that infinite renewable energy that's ideally free, because that's how it arrives from the sun anyway, it arrives here for free. I'd like that to produce hydrogen because that will be the thing that breaks the cost structure and the challenges that we face.
I think there is work to be done. Almost, I'm going to phrase it as internally as well, because there are still companies and very definitely, what should we say, public servants out there who don't understand this either. I think it is changing. I think, let's call it the climate imperative, and how that has been building very rapidly over the last handful of years is changing things. And I think from the perspective of the foundation industries and ours as a challenge, what we have literally seen over 2 to 3 years is mindsets changing rapidly. We started out, and of course we had a group of core companies that were supporting the beginnings of the challenge and were backing us, and they started doing things. But in getting those projects off the ground, we are gradually seeing more and more companies within the foundation industry sectors going, oh yes, you can do it. And that's been happening at exactly the same time as this imperative has become bigger. And indeed, in spending public money, we need to be evaluated on, have we been doing the right things? Have we been spending it well? So we, as a challenge, we will being assessed for that by independent experts. And we've just had a midterm review. And what they've been saying is they are seeing a significant mindset change amongst companies within the foundation industries and their supply chains within the last 2 to 3 years. So it's building and it's changing. So I think the change that we need to see is coming, thankfully.
I would really reinforce that comment that Bruce makes. The journey we've been on over the last 5 years has been from what have you been smoking through to actually this makes a lot of sense. So many of the big major international chemical companies are now looking at what we can do to help drive the journey that we need to go on. The recognition that it's not just about energy-based emissions, it's much more than that. It's about where the carbon's used and how we continue to use it. Because even when we get to net zero through it, and nobody's using fossil carbon for energy around the world, you will still have all the carbon that's contained in your molecules. All of these molecules should be biodegrading, and ultimately that carbon that's biodegraded goes into the atmosphere. So it's not held up forever. It's just a temporary holding slot until we've used it, and then it gets released. And there's been a massive change and a recognition that journey is a journey we all need to go on. So there are many chemical companies now you will see supporting the ambition that we've raised some years ago. And it's nice, when I was just at a conference only last week, the number of people who were presenting the carbon rainbow back to me as a member of the audience as a framework to think about how you manage carbon provenance in an industry going forward was really nice to see. It's nice when people present your work back to you and think they're doing the right things with it. It's great.
Absolutely. Bruce, this has been a really promising start to this Transforming These Foundational Industries initiative. If it continues and it becomes a wild success, how will these industries look differently in, say, the year 2050?
So I think the key thing I want to get across is that these industries are still going to be here, and they are still going to be here at a very big scale in 2050. We clearly need to get vastly more resource efficient in the coming decades. But the reality is that we make something like, I don't know, is it 3 to 4 billion tons of cement a year? Couple of billion tons of steel. So even if we become massively more resource efficient, the demands of a still growing global competition will mean that we will need these materials. Therefore, we have to make them in a sustainable way going forward, no matter how we can minimize in terms of resource efficiency. So what that's going to mean is these companies will still be there. These value chains will still be there. but both how we make the materials will be massively decarbonized, and the materials that they take in to then generate their final products will be significantly different. And Alistair's talked about that a lot as we go through the whole move away from virgin raw materials to raw materials. Some of it will no doubt still be raw materials. You won't be able to get away with it 100%, but you want as much as possible to have come round that circular economy route, back into these. And on that basis, it's going to have to be a much more system-wide thing. Those raw materials can come from anywhere, and that's what we're discovering. And we are discovering literally hundreds of opportunities for that to happen. Now, that is quite a radical change, and I think what it will mean is there'll be a lot more churn in terms of companies within these sectors than there has been historically. The foundation industry sector companies are there for decades, indeed hundreds of years, and I'm sure many will continue to do so because they will absorb the right technology and deploy it and come with the right materials. But others will be challenged by new incumbents, and there will be new players on the scene by 2050. We're seeing it. We're funding some of those companies who we hope will become like that have got radically new ways of producing these materials, bringing them to the table. So the industries will still be there, but I think there will be a lot more churn in terms of the companies within those industries.
How cool. We'll wrap up there. What a time to be a material scientist when even these really mature industries are completely being reborn. That's a really exciting note to end on. Special thanks to UKR for sponsoring these mini-series. This is the first of 5 in a mini-series on these transforming foundational industries. We'll have other ones coming soon on a variety of exciting topics, so stay tuned. And as always, you can find us on social media. We are active on Instagram, so that's the @materialism.podcast. You can always reach out to us at Gmail. That's materialism.podcast@gmail.com. Send us your thoughts on these, feedback. We're always happy to hear it. We would love a 5-star review. That would help other people find these episodes as well. So we'd appreciate if you could do that for us. And we will see you next time.
Innovate UK is the UK's innovation agency. As part of UKRI, they provide over £1 billion per year of government funding for UK organizations to create a better future for inspiring, involving, and investing in businesses developing life-changing innovations. They also support innovative companies to grow through Innovate UK Edge and connect innovators with new partners and funding opportunities through Innovate UK KTN. The Transforming Foundation Industries Challenge is a program funded through Innovate UK. They recognize that decarbonizing the UK's foundation industries is a non-negotiable step in reducing global warming, meeting the UK's net zero targets, and speeding our transition to a low-carbon economy. The Transforming Foundation Industries Challenge is providing funding and support to create a cleaner, more efficient, and more competitive sector that is fit for our future. If you're an innovative UK-based business, or you're looking to innovate in the UK, find out more by searching Transforming Foundation Industries.
The Materialism podcast is also sponsored by Materials Today. You can visit materialstoday.com to stay up to date on the latest happenings in the material science field and read some of the fantastic articles that they've published. You can also head over to elsevier.com to find out more about their journals, books, conferences, and related programs. As always, thank you for listening to this episode of the Materialism Podcast. If you have questions or feedback, please send us emails at materialism.podcast@gmail.com. Make sure you subscribe to the show on iTunes, Spotify, Google Podcasts, or wherever you find your podcasts. And if you like the show and want to help us reach more people, consider leaving a review. It helps us improve and it exposes the show to new people. Finally, check out our Instagram page at materialism.podcast and connect with us to tell us what new material you'd like to hear about next. We'd also like to give a shout out to Alphabot and Colabyte for making the music for the podcast. They both make a ton of really cool synthwave music, and you can go check them out on Spotify and YouTube. Catch you next time.
The inventors of fire, electricity, magnetism, iron, lead, glass, silk, cotton, the makers of tools, the captors of lightning, the architect, the engineer, the musician, are all beneficiaries of the materials of this world and are bound only by their imaginations in manipulating those materials.